Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very afternoon or morning. Okay. Right now, I would like to continue on the another topic under aspiration, which is the aspiration process. I believe this is our chapter 3, right? So I will try my best to explain to you what is the necessary items we need to understand under aspiration process. Right? Let's continue. Okay, here is some of the quotes. I should close that one first. Okay, curiosity is the driving force that propels humanity forward. Okay, so in separation, in chemistry, we also need the driving force, which is the separation force. In ourselves, in our life, we need the driving force lah. Curiosity is the one, okay, one of the thing lah, one of the thing that actually move us forward. Okay, so same goes to science. Curiosity is one of the things that is actually driving force, okay, for science. Without that, there is no development. Okay, so science never complete. We still always evolving, okay, or progressing. Right? Thank you. So it's actually come from the message Mrida. I'm not sure you can Google by yourself. Alright, so for this particular chapter, right, so we will do some recaps on the partition and driving forces, inspiration techniques, and then we will try to look under chemical reaction, okay, which is under that we have a lot of things that we need to understand involved, including the intermolecular forces, complexation, precipitation, and also ion exchange, right? Okay, so now let's recap on the partition separation. As we know that partition is a separation process of similar substances or chemical substances or pure substances by two liquid phases. Okay, by two phases. Okay, so through KD we can measure how hydrophilic or hydrophobic a chemical substance. So it's not it's either KD or KP should be fine. Okay. We already learned about the partition coefficient, and also we have learned about the distribution coefficient. We can calculate them. Okay, if Kp larger than 1, it means that we actually have a better system for separation, right? Okay, so you already know about the term of hydrophilic and hydrophobic. Hydrophilic is the term when the substance love water. Hydrophobic is the term that when the substance hate water. Let's say for this example in this figure, right? Liquid-liquid extraction is one of the example of the partition separation because it's involved two liquid phases, right? So if you look over here, let's say for example the below here we have water and the above one is the organic layer, right? If you look over at the above, let's say for example, your analyte, the orange one, it go to the organic layer. It means that if the Kp you what we call use this as the desired phase or the final phase that you want to extract. Okay, so the Kp should be large. It means that it is hydrophobic because it goes to organic layer instead of the water or aqueous layer, right? Okay, so what are the other examples of partition separation? So I think I would like to leave it to you, okay, to you guys think a bit, and I will ask again this thing during the discussion session. Okay, now let's do some recaps on the driving forces. There are three major types of driving forces. Where is it? Teka. Ada tiga. Okay, the first one is mechanical, often by hand. Okay, take advantage of physical properties such as color and shape lah. Okay, kita guna tangan. Okay, macam ni. Okay, we try to spread the red from the black and to the brown. Okay, brown chocolate. This is chocolate, not berries. Alright. Then we also have the physical means based on the physical properties such as the substance's size, boiling points, magnetic properties, and etc. Okay, in these courses, I'm not really sure if you go on the physical, maybe we have magnetic properties, okay, but a lot we will focus on the chemical based reaction, okay, driving force. So based on chemical properties such as polarity, ion strength, and etc. lah, okay. So if you look over here, example of the chemical reaction, we do have the interaction, okay, the permissible, okay, membrane, or over here they have the polarity, the molecular forces, right? So that is also under chemical reaction. Okay. Right. So now let's focus on the under driving force, chemistry driving forces, which is the intermolecular forces. Right. So actually intermolecular forces involve, okay, in a lot of chemistry exploration. Okay, we will look one by one actually how they interact with each other. But for intermolecular forces, general term used to define the attraction of intermolecular forces between molecules. Remember, the keywords for intermolecular forces is the molecules. If it's ions and ions, we can no longer call them as the intermolecular forces. So intermolecular forces focus on molecules. Okay, focus on molecules. What is the example of molecules? For example of molecules is, for example, molecules of water. Okay, molecules of, for example, paracetamol, right? How about ions? For example, sodium ion, okay? Chloride ion. So they are not involved in the molecular forces. Okay, they involved in the ions exchange, for example. But for intermolecular forces, focus on molecules. So the person that found about the forces, the Johannes Diederik van der Waals. Okay, so the what we call the principle is name of him usually. You don't need to remember any of these, right? He himself have own equation, actually a little bit different. The PV equal to nRT, written by the Boyle, if I'm not mistaken. But you don't need to remember any of the equations, so just equation. Okay, so now let's look on the natural phenomena of the van der Waals interaction. Okay, here is the gecko. I hate lizards, whatever type of lizards, gecko ke biawak ke. I hate them really much. But do you know how they actually sticking themselves to the walls? Okay, because they have the van der Waals, okay, attraction that they can apply. Right. So if you look over here, kat tapak kaki dia, they have a lot of the tiny hairs that we call as the spatulae. So spatulae, they have thousands of it, and it has a lot of surface area because of very tiny hair over there. So they become sticky surface of the substance lah. Okay. So that's why they sticky, and then they can attach themselves to the wall. Right. Okay, maybe later on I will try to ask the class again what kind of the other natural phenomena that you think actually involve the van der Waals forces, right? Okay, the next one is the types of intermolecular forces. Okay, right. So the interaction between molecules, there are three major types of intermolecular forces. Okay, so we have the Keystone forces, Debye forces, and also London forces, or you can call as the London dispersion forces. Okay, sometimes you may know that more commonly as the, for example, dipole-dipole interaction. Okay, dipole-induced interaction or induced dipole interaction. Okay, you guys already, what are these? I'm not really sure if you guys still remember. I'm not really sure when you learn it about it. I kind of forgot. Hopefully you guys get the basic idea. Maybe we can do some sort of refreshment. Okay, but here is the type of interaction of forces. Okay, so dipole-dipole, dipole-induced dipole, and induced dipole. use dipole. So you need to remember this, right? Okay, let's go one by one lah. Okay, now let's go for the first intermolecular forces that we can learn today, which is the Keystone forces. Okay, Keystone forces involve dipole-dipole interaction. Okay, apa compound yang ada dipole? Apa yang dimasukkan dengan compound yang ada dipole? Compound yang ada dipole adalah compound yang permanently polar. Compound yang permanently polar. Contohnya adalah HL. Okay, ataupun kat bawah ni dia bagi sini nitrobenzene. Okay, nitrobenzene. So based on the structure itself is already polar. Dia apa yang menyebabkan compound tu tak polar? Compound tu polar. Okay, compound tu sebenarnya bila dia polar, the compound is polar when the compound itself is non-symmetrical and then they have unsymmetrical in the charge distribution. Okay, selalunya based on the shape itself, okay, or based on the functional group itself, we can already know it is polar or not. Okay, contohnya macam ni, dia tak symmetry and then it has the nitro group, it has the oxygen group that can do the hydrogen bonding. So that's the kind of thing that make the thing have the polar. Okay, dipole mean that dia ada dua pole lah. Okay, dua pole dia ada positif, ada negatif. Maksudnya dia polar, ada satu ke depan, satu ke belakang. Ada yang satu yang love towards negatively charged, okay, ada one towards charged. Okay, so it's permanent. Okay, so that is what we call as the dipole. Okay, how about Keystone forces? Keystone forces stated that about involving the molecular interaction between a dipole molecule and also the dipole molecule lah. So ada dua dipole and dipole lah. Contohnya kat sini interaction between HCl kan. Okay, so contohnya sini HL, okay, and charge and here HL. To the interaction, okay, between these two molecule, okay, but that have the permanent dipole, that is what we call as Keystone forces, or we call as dipole-dipole interaction. Faham tidak? Ditanya Okay, so we moving forward. Alright, still under Keystone forces. Forces exist between neutral polar molecule. Okay, remember, for the Keystone forces, as I mentioned, must be between molecules. So, not ionized, not even an ion. Okay, and the molecule must be polar. Alright, so I think we already learned about the example previously. So the dipole is permanent, or we call them the molecule that contain the permanent dipole. Dipole are two equal but opposite charges, and adding up the resulting charge forces, strength of the force is related to the difference in electronegativity. So that's it about it. So it means that they have opposite charges interaction, right? So between this case, so when they adding up, resulting to charge forces lah. Okay, as more attraction between each other, to increase the electronegativity, right? Okay, here is the how we can calculate the intermolecular forces of the Keystone forces. Do you need to remember any of it? You don't need, I think. I think so lah. I hope so as well. But I will advise Dr. Amy to not off any calculation for forces examination, unless we provide you with the calculation for the Keystone forces, assignment, then it can be operated lah. But I just want to mention here, okay, the differences between the in the Keystone forces, the differences of the formula between identical molecules and also different molecules. If you look over here, let's say for the identical molecule, the interaction between HCl and also that is what is meant by identical. How about different molecules? Different molecule, for example, HCl and also HNO3 for example. Okay, so you have different molecules. That is what is meant by identical molecule. And then if you look over here, then be lah. Okay, as A, K, B, not much differences except for this one. Okay. So you have to you the dipole molecule A and also the dipole of the molecule. That's how you can differentiate. Clear lah. The other thing is about the same lah. Whereby you can look at information here, right? Okay, now let's look on the. Okay, before we going further to other type of the intermolecular forces, including the dipole induced and also the induced interaction, I need to explain a little bit about polarizability. Okay, what is meant by the polarizability? It means that it's a tendency of matter when subjected to an external electrical field source to acquire an electric dipole moment in proportion to the applied field. The molecule distorted from its normal shape, which may be caused by the presence of nearby ion or dipole, or in an easy way lah. Okay, let's say you have a compound that is non-polar. Okay, over here, when you have another source, okay, come to you. Okay, either it's electrical field source or a polar molecule lah. Okay, polar molecule. So when it come closer, it can induce the dipole moment on this particular compound or molecule. So daripada compound ni, yang molecule ni yang tak polar tadi, bila dipole ni datang dekat, bila dipole ni datang dekat, okay, so bila dipole ni datang dekat, so dia akan induce this dipole, okay, dan dia akan terinduce lah. Okay, so dia akan induces this dipole. So this molecule dia akan induce, okay, induced, okay, dipole. So jadilah induced dipole. Okay, so bila apa jadi bila molekul ni menjauh? Dia akan jadi balik kepada bentuk yang asal. Okay, so the polarizability is mean that it can have a momentarily can a potential, okay, momentary potential to momentarily change dipole. Okay, so we call that induced dipole. Kalau kata kita tarik daripada dipole ni keluar, dia akan balik pada bentuk asal. Okay, right? Okay, next one, after we already learn about polarizability, what is meant by that. Now we can focus on the other type of the intermolecular forces, which is by forces. Okay, I'm not sure how to call it dB or dBi. Okay, as long as it's okay, I can understand. Okay, it should be okay, right? So a permanent dipole can induce, okay, a temporary dipole to form in a non-polar molecule. Macam saya cakap tadi, ada satu molekul yang polar, dia akan boleh induce, okay, non-polar molecule ni kepada polar ataupun dia menjadi dipole. Okay. So if you look over here, when permanent dipole come and do some interaction over here, it can form momentary dipole. The non-polar molecule can form momentary dipole. So example over here, okay, the benzene, okay, as the momentary dipole and the nitrobenzene as the permanent dipole lah. Kita boleh bayangkan dekat sini ni okay, so kita boleh bayangkan dekat sini yang mana satu benzene, mana satu nitrobenzene. Which one is benzene, which one is nitrobenzene? Okay, this one permanent dipoles, see, nitrobenzene lah. Okay, nitrobenzene. Okay, this one is benzene. Okay, right? So in the dBi forces, the formula is different. Okay, we have the dipole moment and the polarization of molecule or atom, and then between two. Right, that's it about the dBi forces lah. Now let's look on the other type of the intermolecular forces, which is the London dispersive forces. Okay, London dispersive forces is the weakest among all. Saya terlajak It's the weakest among all. Is actually a temporary dipole forms in a non-polar molecule, which leads to a temporary dipole form in another non-polar. Okay, usually, London dispersive forces occur between non-polar molecule, but I need to mention over here, it can also occur in the polar molecule, but on the non-polar side. And we will discuss a bit that. Okay, so what happens is when the molecule, non-polar molecule, they come close to each other, when they add the orientation between the positive and negative charge of orientation of the electron, at the molecule, they come close, they will form the momentary dipoles. Okay, both of them is dipole, induced dipole. Okay, but we need understand that the dipole moment between them, interaction between them is the weakest one lah. So, you tak boleh bayangkan dia terlalu mempucur lah. Mungkin dia pucur sikit je. Tak berapa nak bulat. Sikit je. Okay, dia tak bujur macam dipole-dipole interaction. So, it just induce dipole lah. Very minimum lah. That's why they have the weakest interaction. Okay. Right. So the example here is the benzene and alkane lah. Okay, this question is the only intermolecular interaction that occur between non-polar molecules. Okay, so presence is all molecules polar and non-polar. Why I said in polar also they can interact. For example, you have this position. Okay, you have this position between two molecules. Here is Cl, and then I hate drawing. You have this particular position. Okay, when they at this particular position, okay, it can be the formation of the London dispersive forces, but the interaction is the weakest lah. I say. Okay, so a temporary entry forces result when the electron is in the adjacent atom of position that make the atom form dipole. Right, so how it's happening because of the constant motion of the electron can develop a temporary dipole when its electrons are distributed when they are reacting with each other lah. So it will cause the constant motion of the electron when the movement of electrons, orientation match, so they will form the temporary dipole. This figure maybe is not accurate. Tak ada lah this bujur sangat mungkin bujur sikit je. Okay. Right, now let's look on the van der Waals forces related magnitude between molecules. So kita tengok. We have learned about the dipole. Okay. Dipole. And then we have learned about the polarizability. Right. So now we look at the forces, the molecular interaction, which is He-som by and also London. Okay, if you look there, He, helium. Helium is inert, right? So it will not form with any supposedly. So with his alone, non-polar. Okay, alone, non-polar. So it's supposed to have none of the He-som divide lah. Right? Right? So it has weak London dispersion lah when it interact molecule. Cannot do He-som divide lah. Yeah. So if you look over here, polarizability also not that great. Usually when the polarizability is high, okay, usually it means that the molecule is also polar lah. So polar. Okay, right. Okay, the more polar the molecule, the more mission of polarizability lah. Okay, so the more polar it is, right? So let's go for example here HCl. Okay, polarizability is 2.63, quite huge. And then if you look here, the dipole force of the molecule is 1.03 because it's polar. It is polar. Okay, if you look over here, He-som and Debye forces is quite huge as well, and can also induce what? okay, for the London interaction. So let's say HCl, right? HCl, okay, maybe the interaction is maybe something like this. Cl, H, they can have interaction. They can have the London. Okay, right. So what else information over here? Non-polar noble gas, no orientation and forces compared to dispersion force. Okay, noble gases lah, because they are alone. Okay, polarizability increase, dispersion forces increase. Okay, as the polarizability increase, the dispersion forces also increase. Okay, so increase the polarity lah. Size and polarizability increase, the moment decrease. Okay, as the size, okay, and the polarizability, if the size, okay, and the polarizability increase, but the dipole moment will decrease. Hence, dispersion forces increase, but orientation and induction forces decrease. So, a lot of information over here, right? Okay, so now let's look on the other type of the intermolecular forces, which is the hydrogen bond lah. Okay, so form between molecules containing hydrogen atom bonded to electronegative atom like and Fn lah. So it must have interaction between hydrogen with the oxygen, nitrogen or fluorophore lah. Okay, so if we have this, no fluorophore, fluoride. Okay, so if we have this kind of interaction, so we call this as the hydrogen bonding. Okay, hydrogen bonding, it is one of the strongest intermolecular forces. Okay. Right, so here is summary of the intermolecular forces. So we can look at this chart, fractal molecules or ions. If the ions are involved, okay, we need to check either it is a mix. Polar molecule and ions are both present. It means that the molecule and ions are together. No, it means that it's just, okay, if there are both ions and molecules, we call as lah. But that is not about the molecular forces lah. Just interaction between molecules and ions or ions. Yeah. So we are now focusing on this part lah. Okay. Right, for intermolecular forces, this part we're focusing on the molecules. So let's say there is no ion involved, the molecules are polar. Okay. So if the molecule is no polar, okay, if the molecule is no polar, both of them, so it will be used in use. If the molecule is as polar, okay, it can be hydrogen bonding or dipole forces lah. It depends on the, if let's say for example you have hydrogen and nitrogen atom also, it can involve the hydrogen bond. Okay, a lot of things can happen. Right, I think we already learned about the intermolecular forces. Okay, that is the basic idea how the interaction between molecules. Okay, so now let's look on another type of chemical reaction. Okay, we can form for the reaction section. Okay, I hope you guys still remember about the gravimetric analysis where we actually apply the complexation. Okay, during the experiment, we actually try to extract or separate, okay, the nickel from the solutions. Okay, we can calculate of the solution. Okay, so the complexation is the thing that actually performed during the experiment. Okay, so complexation is the complex species formed by the reversible or irreversible association of two or more interacting molecules or ions. So it can be interaction between molecules and molecules, can be interaction molecules with ions, or it can be interaction between ions and ions. Okay, the interaction can be covalent or non-covalent interaction between two or more compounds that are capable of independent existence. Okay, so the interaction can be covalent or non-covalent. Covalent is mean that it can be between organic one, okay, or ionic compound. Okay, so they are capable of independent existence. What it means by independent existence? No formation of new product lah. So they will not change the structure of the they will not change the structure of the either of the chelating agent or the target compound, but they will just somehow merge together lah, attach lah, the right word I think, attach. Okay, complexes also have been usually referred as coordination. I think you guys already learn about I'm not sure if you guys already learn about coordination compound or not. So as I mentioned here, the interaction can be a lot: organic, inorganic, or organic. Okay, so we have the inclusion type as well. Okay, so in the complexation lah, in the complexation, once the complexation occur, the physical and chemical properties of the are altered. Okay, so mungkin dua-dua tu soluble. Okay, but when they form the complex, they lost the solubility. That's why we can do gravimetric. But remember that they are not forming a new product. They just merge together. That is what it mean by decomplexation. So we can still separate them actually. Okay. So complex formation usually alter the physical and chemical property of the drug. For example, cyclodextrin used to complex many drugs. Okay. So cyclodextrin also used pressure to desired compound effect. This to other lately they try some researchers try to introduce a greener method to much more efficient extraction method in certain metrics. So how they do it, they utilize the chelating agent to trap the desired drug, and then they will detrap the analyte. They can analyze in chromatography method first. So a lot of application complexation expression. Okay. Now we already learned about the complexation. I can go to the precipitation. Okay, because in the precipitation also can be occur through the formation of new product, or it can occur through the complexation lah. Okay, a chemical reaction causes the formation of sparingly soluble substance that precipitate from solution is filtered, washed, purified, and weighed. Okay, gravimetric lah. Okay, alright. So in the precipitation, we cause the formation of the insoluble substance or sparingly soluble ataupun low soluble substance. Daripada kita try formkan chemical analyte itu menjadi satu kompleks atau satu chemical yang baru yang kita tahu je punya substance tu apa, dan kita boleh check lah dia apa kan. Okay, so it's useful for determining soluble analyte through weight measurement of pure substance containing the analyte lah. Okay, maksudnya kita analyte tu kita combine dengan something else yang lain, dan kita boleh tahu melalui calculation lah, a lot of calculation as you already done on the gravimetric. Okay, so based on the compound, let's say for example AgCl, you can trace back for the amount of for example chloride in that particular solution. Okay, so here is for example, contohnya lah, you nak kira yang ni tapi you tak tahu berapa kan, so you tambah the coagulant ataupun you tambah the another material, so they will form another material, then we ask from the known amount of this particular reagent at right, then you can calculate how much actually the targeted analyte lah inside of this solution, as you have done in gravimetric. So the precipitation method you can do through the determination of analyte, which precipitated by a precipitating agent through either formation of new product, compound, or complexation lah, sama ada formation of new product ataupun complexation. Okay, the precipitate is slightly soluble macam kita tahu, or it can be converted to one of known position. Okay, so kalau kita tengok kat sini, ini antara contohnya bila kita kata we add something, dia akan menjadi satu produk yang baru, AgCl. Okay, so you know that Cl, so for example the unknown is Cl, but you know that it will interact with 1 molar of silver. Okay, so based on this you can trace back lah, calculate. Okay, what is the amount of the chloride inside of your solution, okay, inside of your sample. Here is, for example, another example, precipitation through complex reaction. Alright, now we look into the relative magnitude between molecules. Okay, here is the table. Right, let's look at the example over here. We have few molecule over here, and then this particular color for the polarizability, and then here is the dipole moment interaction between the molecule, and then isi pada molecular volume or the molecular size is about the same thing. Then we look about the forces lah, Kisum divide London. Okay, if you look over here, right, the helium, okay, helium is noble and non-polar, okay, by himself, they will know what we call the three kutub lah, the dipole moment is zero lah, okay, because it's nothing, it's non-polar at all, okay, so it's zero. And also if we look over here, it also have a very weak London dispersion force because it has very low polarizability. If we compare, okay, with someone with have high polarizability, it will have quite very good London dispersion force. Okay, so let's compare with the compound which is the polar, for example CO, okay, 1.99. If you look over here, 1.99, and then because polarizability, it will have 1.99 is quite huge polarizability. It will definitely have very huge force of London dispersion force. If you look over here, because the compound is polar, it will have the dipole moment 0.12. One thing that I would like to explain over here, that if you look at the HI, okay, because of the isi padula, the size of molecule is quite huge, okay, even though it has high polarizability, but because of the size, okay, it will reduce the attraction force between molecule, okay, because of the size lah, because charge lagi besar, lagi jauh lah kan dia punya kuasa tu nak dekat, so the attraction tu akan makin lemah lah bila size tu besar. So if you look over here, the dipole moment, okay, is not that great, even though it's polar, okay, even though it has very good polarizability, right? If you look here, okay, the dipole moment here is not that big lah. Let's see, the Kilom and dB is not that great compared to HCl, which the volume also low, and let's say for example H2O here, the volume is big, okay. So if we can look over here, the dipole moment is quite big lah, okay, and also the force, the Kilom and also divide, okay, right? That's how you can understand relative magnitude between molecules. Alright, but we need to know that not all insoluble precipitates are well suited for gravimetric analysis. It is important to consider what properties are required in order that precipitate be applicable for quantitative precipitation method. Okay, contohnya kita nak analyze through gravimetric. Tak semua precipitation ni, okay, kita boleh, maksudnya ada certain requirement yang kita perlu capai untuk kita boleh guna untuk gravimetric analysis. So we need to fulfill the requirement involving the solubility, filterability, chemical composition or other desirable properties lah. So yang ni requirementnya lah. Okay, so kalau kita tengok kat sini, right, precipitation on the solubility, the product must be sufficiently insoluble to prevent the loss of weight. Okay, ini dia punya syaratnya lah, what we call as the syarat, the rule or regulation, not the rule. So, apa kita panggil? The right term, syarat lah. Okay, right. So filterability, precipitate form should be adaptable to simple and rapid filtration method. Kalau kata gravimetric, it should be adaptable to simple and rapid filtration method. Okay, so dia mestilah insoluble dan kita boleh filter dia. Kalau kata even dia insoluble, kita nampak dia, okay, tapi kita nak filter dia tembus. Okay, so it's not use, tak boleh jugalah, okay, not suitable lah. Okay, Then the chemical composition, the product must be of known chemical composition. Kita kena tahu uh, the chemical composition. Kalau kata contohnya kita tak ada targeted analyte yang kita tahu, kita just letak the chemical everything, dan kemungkinan kita salah, contohnya macam DMG, dia boleh form juga kompleks dengan ada analyte. So that the chemical composition yang boleh occur kan. Macam you buat gravimetric dulu, DMG, when you discuss I'm not sure if you have discussed the report that DMG also can also form coordination complex with other kind of metal. Okay, so need to be careful. Okay, so other desirable properties that can affect the stability and purity of the precipitate. Kalau contohnya macam saya cakap tadi, kalau kata dalam that particular matrix sample you have other kind of the impurities that can affect the purity of the chemical composition, okay, so it will give result, okay, when you do the gravimetric. That is the requirement lah for the gravimetric under the precipitation. Okay, now let's look on the, I think the last one lah in the chemical reaction, and also for the separation forces, okay, under this chapter. Right, for the ion exchange, okay, is a reversible chemical reaction wherein an ion from solution is exchanged for a similarly charged ion attached to an immobile solid particle resin. Okay, so it's a reversible, okay, again a reversible, okay, wherein an ion from solution they can exchange, okay, with the charged ion attached to the resin. Okay, for example, here is the resin, here is the original molecule. For example, I put it, okay, maybe I will show in the next slide lah. So they actually reversible. So B replace A, okay, and then A can replace B. Or maybe you want to use B to replace A, and then you can use in the next step can use C to replace B, ataupun sorry, C is minus, right? So B to replace B, B plus to replace B. So where is the application of the ion exchange? Where we try water softening or water purification, when we try to separate the for example magnesium, okay, from the hard water. Okay, we want to make it soft water, so we can separate the magnesium, okay, through the water softening process or water purification lah. Okay, so in the water softening used to replace magnesium and calcium ions found in hard water lah, sodium ions. So water containing magnesium, or it's hard water lah. So you guys already form the titration process, right? Okay, if I'm not mistaken, titration if I'm not mistaken, right? Okay, so you can also do the water purification, remove poisonous heavy metal, okay, by replacing them with more not heavy metal or poisonous ions such as sodium and potassium. And it's also applied in the ion exchange chromatography. So we're supposed to have the title over here, the application of the ion exchange, supposedly, yeah. But it's not there. You can write, okay. So let's go to this figure, okay. Right, if you look over here, here is the example of the softening process. For example, you have the water, okay, hard water over here, and then here you have the resin with the sodium ion. Okay, so you can pass through the hard water over here, so the magnesium will get attached to the ion resin. It will replace the sodium. And then if you look over here, only softened water containing sodium, okay, will maksudnya, okay, the consumer. How do we remove the hard water? Okay, so let's say you want to remove, okay, the magnesium, you want to recharge the process. So what you can do, you can remove the magnesium ion as the hard water. So you can apply, bring the solution, okay, containing sodium, back the magnesium ion. So the magnesium ion, they will remove as the wastewater. Reversible process. Okay, so that is the process lah. Kata masih ada, okay, nanti bertanya the discussion section. Right, that's it for the separation forces. Okay, right. if you guys have anything to ask, go on. It's us to the discussion. I will explain. I will do my best to explain my best. Yeah, right. Thank you so much and bye.